So the LCD then. When I say LCD, I mean the whole thing with the LCD on, the rotary encoder, the stop button and a buzzer, and oh yeah, it's got an SD card slot in it as well. Not that I use that. Now, there's a long version of this story and there's a short version of this story. And the short version is, like I said at the end of the last video, I have it fixed. The long version, yeah, I want to try and get somewhere between the short version and the long version. Otherwise, somewhere along the line, I need to try and get something that might be useful to somebody else over in this video without it banging on for hours. The LCD was about the only thing that didn't really work out of the box, or at least as it should do. So you can't really complain. For the price of this stuff, it's a miracle that everything else works. So somewhere along the line, something wasn't going to work properly. Probably and properly. In fact, definitely and properly. So the issue is that the LCD, after a given amount of time, and it kind of varies, but it's not too long, usually somewhere around about a minute to a couple of minutes after the printer's turned on, and especially when it's printing, for example, will go corrupted like this. So what happens is that the display starts shifting into different directions, and it will shift over off of one side of the screen and start overlapping back onto the other side of the screen, and this gradually gets more and more garbled, and eventually it will just display nothing entirely. And when this problem sort of first reared its ugly head, I wasn't really that concerned. The wiring was all over the place. In fact, the ribbon cables that connect the actual LCD module to the ramps were literally wound in between some of the wiring going to the stepper motors. So I just thought, yeah, it's interference, probably to be expected. However, when I sort of somewhat more carefully separated those wires out, it really made no difference, and it was just as bad. So, I was almost 100% convinced that this was just noise coming from the stepper motors. So I took literally everything else off of the ramps, and including the stepper motor drivers, and it made no difference. In the same amount of time, give or take, the screen would corrupt. So I needed to investigate further. Mixed in with this issue on the LCD was the fact that I wanted anyway to replace the cabling that runs from the ramps to the LCD. As it comes, there's two 10-pin ribbon cables that connect the LCD to the ramps, and that really wasn't going to work because I want to mount my LCD module on a flexible arm, and the ribbon cables weren't a good way to go. So those two things combined with the corruption on the LCD and me wanting to change the cable and me wanting to finish off the thing finally, I wanted to try and find the source of the interference and the problem with the corruption on the LCD before going ahead and doing the new cable and putting it all back together so it would be just fixed. So my first sort of port of call really was to try and see if where the interference was coming from, because I'd kind of taken, like I said, everything off of the RAMPS board. So I couldn't do any more with that. It definitely wasn't coming from the drivers because they weren't even on the board. In fact, nothing was on the board. So what I wanted to do, and I thought, it might be some issue with wiring on the actual LCD module itself. So I had a good look at the LCD module and did a bit of searching on the internet to try and find, some kind of schematic showing the all of the wiring for the traces, the pinouts and all that kind of thing for the LCD module I have, which is called a bigtreetech.com rep blah blah blah, yeah, like that. But I really couldn't find any schematics for that specific module, and I really couldn't find any that gave me much confidence, but I did find lots of different ones and bits and pieces. So together with these sort of things that I managed to dig up off the internet, and spending probably about half a day with a multimeter measuring all the pins, all the continuity, to see where each pin from the connector ended up actually on the board, components and all that kind of stuff, I finally arrived at a schematic for the board. That all took a lot of time, which is why that's part of the long story. It took a long time to find some clues on the internet. It took a long time to meter it. So the short part of the story is I have now made this into a full schematic end-to-end that shows the pins from the Arduino or from the ramps, but mostly they go all the way back to digital pins on the Arduino, all the way through the connectors to the components on the LCD board. And of course this schematic is available on my website, which is linked below. So what I did once I found out what each of these pins did from the connector is I disconnected certain parts of the ribbon cable that were unnecessary for what I needed. Everything to do with the SD card, disconnected that. Everything to do with the rotary encoder, disconnected that. The buzzer, everything else, and just left the 3 pins, which is all that's required, well, plus the 5-volt supply and ground. But on top of that, there's only 3 data pins that drive the LCD, because it's a serial connection on there. And with that, just that connected, same problem. So I connected the LCD to another Arduino, an Uno, and just flashed it with some graphics samples, and let that run for a minute. And yep, this is what happened. It also goes corrupted in exactly the same fashion. So it is a problem with the LCD module. It's probably down to the fact that it costs absolutely pennies to make. So I would imagine that some of the components on there are, well, let's just say subpar. So not wanting to give in and shell out for another LCD, which may well have the same problem unless I paid a lot of money for it, which I wasn't going to do, I started playing around with the instruction timings in the Arduino Uno sketches, the sort of test sketches I was using, to try and slow down the data being written from the Uno, or the Arduino Uno, yeah, same thing, to the LCD. And eventually I could slow down the instructions so that the display was still sort of functioning fine. Obviously slower refreshes and stuff like that, but that's no big deal. But it wasn't corrupting, importantly. So yeah, that kind of then led me to think, well, I just need to slow down the instructions in Marlin to the LCD, and that should solve the problem. In between all of this, I decided to use a decent, and I say decent, an HDMI cable. Just bought an HDMI cable. It was only a couple of pounds, can't really remember. But I bought one that had the steel or aluminium braiding around the outside underneath the plastic coating, so that I could earth that and yeah, provide a little bit of extra noise protection from the cable. However, an HDMI cable only has, well, yeah, ignoring the shielding that's inside, it only has 15 cores. So that meant I had 15 wires to play with and 20 connections. So whilst I was there digging around with all of these connections, I hunted through and found a number of connections that are not being used or not even connected whatsoever on my LCD module, and that's all shown on my schematic as well, which is linked below. In a concise version, I managed to save enough connectors so that I could use the 15 cores or internal wires of an HDMI cable. Earthed them as well, so they all go down to an earth that comes from the power supply and then goes off to the main AC earthing of the building. So using the schematic that I sort of created from all of those different files I found on the internet, including the Gerber files for the ramps, so I could actually see what the trace is, where the traces go on a ramps, and how that coincides with the Arduino. I checked everything because I just wasn't trusting anything at this point, none of the schematics, and confirmed that everything is going to the right place on the Arduino. And then lots of crimping later of lots of DuPont pins, I ended up with this, well, one end of this. I decided to skip the actual adapter because I didn't really need it, and just used DuPont connectors straight onto the auxiliary 3 and auxiliary 4 ports of the ramps board. So that was my new cabling sorted out, and so I ran it again, and actually it was significantly better with you know, some of these cables individually grounded, shielded, and the whole cable on the external braiding shielded. It did make a bit of a difference, but it still eventually corrupted slightly. It would sort of shift maybe a couple of pixels every half an hour. But anyway, that wasn't good enough. So I needed to return to slowing down the instructions to the LCD from Marlin, or from the Arduino, via the ramps controlled by Marlin. So I started having a look at how this could be done, and I came across a post which I will also link in on my website on the notes for this particular video. A forum post from the guy that actually wrote the coding for, I don't know if it's all of it, but certainly for the LCD part of Marlin. And it turns out that he has built in some way to slow down, or at least put some pauses between the bytes being sent to the LCD from Marlin. It doesn't seem to be documented at all. But it's in there, and in fact you can even put these into the configuration H file. They're not there by default, but you can put them in, and you can basically add some delays in between the instructions that send data to the LCD to effectively slow it down. So where you've got a noisy situation, which is kind of what this is really, it's a combination of a little bit of noise, probably just power noise, who knows what, and the components on the LCD not being good enough to keep up with the data coming from the RAMPS board, or the Arduino really. So yeah, I sort of chucked these in, and it's not, as I said, it's not documented at all, but reading between the lines, the basic idea is that these three parameters here allow you to gradually increase the timing, introducing no operations into the code. So obviously there's a balance here, because the more no ops you introduce, the slower the whole of Marlin's going to run, which isn't great. So you need to be a little bit careful. So I started out with sort of 0, 1, 1 or something, and it sort of turned out that what worked for me in the end was 1, 2, 1. So you want to basically minimize the sum of these, and 1, 2, 1 is 4. But basically you want to minimize the sum of them, and I think the general gist is that you don't want to load up any one in particular, so you spread the gaps, or the no ops, the delays, as equal as you can between these three. Beyond that, I don't know. I haven't looked any deeper in the code to find out when and how these are used, but certainly with that and the shielding that I've added to the cabling, I now have an LCD that, at least for 8 hours or 10 hours that it's been running for in tests so far, doesn't corrupt anymore. So that is the sort of medium length version of how I got the LCD module all up and running. Yeah, one thing I will say is that I kind of needed to do both, as it turned out in the end. I needed to change that cable that connected it anyway, but if I disconnect the earth from the cables and run with the same delays introduced, then I get corrupting again. So in my case, it's a sort of combination of protecting the signals a little bit from noise, and also slowing down the signals. Of course, all of this may very well be completely different on what you're using. The LCDs, well, who knows, maybe even ones from the same company are completely different. That's the nature of low quality components, really. And yeah, that's about it for the LCD. It is now sort of mounted. In fact, since I fixed the LCD, I have put all the electronics back together. It's all sort of mounted relatively nicely, and very nearly completed, but we'll discuss that in the next video.